Hello everybody, welcome to our video today where we are talking about organic chemistry, chapter 6, aldehydes and ketones, part 1. So, some of this has already been discussed in a little bit of, just general in previous videos, but this is specific and hopefully it gives you a little more details to better understand the concepts as a whole. So first, just a little bit of review. We have aldehydes and ketones. Aldehydes, you have your R group attached to a carbonyl carbon with a hydrogen, so this will be found at the terminal of a molecule. And then we have ketones, which is an R group attached to a carbonyl carbon attached to another R group. Okay, so the only difference is you have a hydrogen here and another R group here. However, they both have a carbonyl carbon, and by that I mean a carbon double bonded to an oxygen. And this carbonyl carbon is electrophilic. It's a very common electrophilic molecule that you will see on the MCAT. And this is because there's a dipole that's created with this oxygen. So this oxygen has lone pairs, and this double bond to the oxygen creates an electron withdrawing group, right? Which causes these electrons to be pushed up a little bit and creating a dipole moment. So here we have a partial positive charge on this carbon, right? Because oxygen is very electronegative, so it's pulling these electrons close to it, which means that we're leaving this carbon partially positively charged and giving it a dipole. So when this happens, we can use it for so many other reactions. So first, let's just get a couple of examples for nomenclature for these for things specifically. So we have methanol with an Al at the end, right? It's just hydrogen, carbonyl carbon, hydrogen, methanol, which is also known as formaldehyde. Then we have ethanol, Al as well, carbon, carbonyl carbon, and hydrogen. And we have propanol, again with the Als at the end, carbon, carbon, carbonyl carbon, hydrogen. And again, these names, are also common to come up. So just know formaldehyde, acetaldehyde, and this one I personally haven't seen as often, but propanoaldehyde. But yeah, just be able to name those ones. And then if there's a cyclic ring attached to it, it would be known as a carbaldehyde. Okay? So just some basic information before we get into the more difficult things, which are on this side of the board. So again, this red part is a little bit of review, but personally I had to learn this oxidation so many times that it wouldn't hurt to listen to it again. So aldehydes can be produced by the oxidation of a primary alcohol by PCC. Okay, so we have an aldehyde over here. This is what is produced if you have a primary alcohol that is becoming oxidized, right? If it's becoming oxidized, again, it's gaining a bond to oxygen, which is what we see here between an aldehyde and an alcohol, right? So aldehydes will be produced by oxidizing a primary alcohol by PCC would be the reagent used, but stronger oxidants will actually oxidize it further all the way to a carboxylic acid. We will look at this in a later chapter, but just know that if you use a stronger oxidant, you will, pass the aldehyde stage and you will go fully to carboxylic acid. Ketones, on the other hand, are produced by the oxidation of a secondary alcohol, and the ketone will stop, it can no longer be oxidized past the ketone stage. If we look at them, the difference, right, is that the aldehyde is on, it makes sense conceptually that this is the case because we're looking at this aldehyde that has a hydrogen on this end. The difference between an aldehyde and a carboxylic acid is we would have another O here, right, which is still dealing with this kind of end of the molecule over here. So if we have a strong oxidant, it will take this and turn into a carboxylic acid. But if we're looking at a ketone, you're not really going to get a carboxylic acid from here, so you don't need to worry about oxidizing it past the ketone stage, if that makes sense. And when I finally understood that, the order of the oxidation and what's happening and why is a primary, secondary alcohol, that started to make sense. So hopefully now that makes sense to you. We do have a couple of general reaction types that are also covered in this chapter. So we have a hydration reaction where we have a carbonyl carbon plus water, which will give you a gem diol, for example, and it's a gem diol because there are two diols, two hydroxyl groups, and they're coming from the same carbon, so they are gem diols, okay? Next, we have aldehydes plus an alcohol, okay, which we have shown here. Above, just make note, above all four of these arrows that we're about to talk about, there is an ROH above the arrow. I didn't have space to necessarily draw it, but there is an ROH above it. And let me just get this. Yeah, so above all of those arrows, there's an ROH, okay, which means there's oxygen with lone pairs, an R group, and hydrogen. And before I get into specifics, I'm going to bring your attention down here to the red so you know what's going on at the molecular level before we look at, you know, this plus this equals this. Before we actually look at the reactions, let's look at the specific details that's happening, and you'll be able to understand. So if we have, I'm just going to do this in real time so you can see. So if we have this aldehyde, right? And we have, like I said, plus this ROH. What's going to happen is the lone pairs on this oxygen. Remember how we said this is a partially positive charge on this carbon. So what's going to happen? These lone pairs are going to be attracted to that carbonyl carbon, which is going to force these electrons to move up, right, and break that bond. So then you're going to be left with this. And again, I will draw this in real time so that you can see it. So then what you have is a negative charge on this oxygen, right, because this bond was just broken. And you have this group attached to this carbonyl carbon, right? So what then happens is a hydride shift, and we have this negative charge being attracted to this hydrogen. So it's going to pull that hydrogen off and create an OH group up here. And then these electrons are actually going to go back to the oxygen, because right now when this oxygen has 3 bonds, it has a positive charge, right? Because it has 3 bonds. So you're going to take this hydrogen off. And when you take that hydrogen off, the electrons in this bond of the OH are going to go towards the positive charge. And that is when you're going to be left with this right here. This is the basis of these two reactions that we're going to go through, but I just wanted to show you what actually happens and how it happens. But just as a general foundation, it would be really great to know just, you know, the products and reactants of these two things. Okay. So we have an aldehyde plus an alcohol. Okay, so if we have our aldehyde and our alcohol, we will get a hemiacetal. However, when another equivalent of alcohol is added, you're going to get an acetal. Okay. Then we have, the difference here is we have, see how we have the OH and we have an RO. So that's the difference between the hemiacetal and the acetal. So they both have a hydrogen, they both have an OR group, but then this group up here is an OR and this one is an OH. So that's between a hemiacetal and acetal. And to get to the acetal, you're just adding another equivalent of alcohol. So basically it would just be another ROH to get to an acetal from an hemiacetal. So then we have the same type of reaction as we discussed, but it's going to be a ketone plus an alcohol. And this will give you a hemiketal. And then with another addition of alcohol equivalent, one extra equivalent of alcohol, you will get a ketal. So again, the difference between the acetal and the ketal is the acetal has this hydrogen, right? Where the ketal does not. And that kind of makes sense with the words of aldehyde and ketone, right? We have an aldehyde with a hydrogen, ketone with an R group. Same thing here, the acetal with the hydrogen and the ketal with the carbon instead. And then as we mentioned above, the same process from hemiketal to full ketyl, okay? And you can see the difference here is an HO group, and then here we have an RO group. So yes, that is kind of the basics of the reactions that you should, study and know what you're gonna get for aldehydes and ketones. Another thing that was mentioned in this chapter, before I forget, was that nitrogen and derivatives react with carbonyls and they create imines. And then we have hydrogen cyanides that react with carbonyls to produce cyanohydrins. Now, I did not draw these things out. I believe they're lower yield than the other stuff, but you could look up an image of maybe an imine and a cyanohydrin, just so that you can be able to recognize those things. But I know this was kind of a lot. Hopefully this sketch down here made sense of what's actually happening to these molecules in these stages. In those reactions. But if you have any questions, please put them below. And if not, we'll see you in our next video.